Okay, so 3, 2, 3, 3, we're kind of combining a little bit. We're going to look at stem and leaf plots. We're going to look at frequency distributions, which we sort of talked about yesterday. And then we're going to look at histograms. Because there's a difference between bar charts, with what we did yesterday, and histograms, which is what we're doing today. So first thing, we sort of did this in chapter 1. I'm not going to go through and do another example, but a dot plot is a simple way to display numerical data when there's data sets reasonably small. Again, just make sure you have labeled the axes in the scale clearly. Like I said, we did one of those in chapter 1, so I'm not going to go through a ton of them. I think you're okay. More importantly, what we're going to see within the next couple chapters is a stem and leaf plot. Oops, I don't need plot. It's another way to display a relatively small numerical data set. So yesterday we did bar charts. Those are really for categorical data. Today and tomorrow, really what we're looking at is numerical data. So in a stem and leaf plot, the stem is the first part of the number and the leaf is the second part of the number. So if you have like numbers with triple digits, the stems can be 2 numbers. So here I have male weights, 97 pounds to 225 pounds. So what's important with a stem and leaf plot is to always have a key. I prefer to write my keys this way. 1/4/7 would be 147 pounds. On the answer keys that you'll see, they'll do like the stems is the 10, the leaves is the 1s. It doesn't matter what you do. I prefer this one just because I never remember my placements of my digits. It's just not something I remember. But either one of them is acceptable. Again, the numbers to the left of the lines are the stems, and the numbers to the right are the leaves. You must include a key. Leaves should be single digits with no commas. It's best to have the leaves that are in numerical order, but it's not required. Especially when you're trying to find, like we'll get to in chapter 4, like the median. You want it in numerical order, but it's not necessary, especially like on a quiz or a test if you're rushed for time. Stem plots look very similar to a dot plot of the same data, but stem plots preserve the individual data values. So sometimes it'll just be called a stem plot instead of a stem and leaf plot too. So when data set's very compact, sometimes it's useful to split the stem to stretch the display of to investigate the shape, which we'll talk about in chapter 4. So this is called a repeated stem and leaf plot. So like if I look at the body temperature down here, it's only from 96 degrees to 99 degrees. So what we'll do is we'll like end up doing 96, 96, 97, 97, 98, 98, 99, 99. Just extend that. Okay, so for my lower, it's just like rounding rules. You do 0 to 4. Higher, you do 5 to 9. So my key here would be 99/5 would equal 99.5 degrees Fahrenheit. Okay, so, and if we had a title, we'll put it at the bottom. It's body temp. So then here I'd have 3, and then I'd skip. And as you're doing the leaves, one thing to keep in mind is make sure that they're evenly spaced, just like the dots. You don't want like 3 numbers in the same space as 5 numbers. So 97 will go up here, 97.8, 1, 1, 3, 5, 6, 7, 8, 0, 5. So it just spreads it out a little bit more. I feel like I missed one. I did. It should be 6, 7, 8. There should be 5 there. So it just gives you a better idea, a little bit more spread out. But you really only need to do this if the numbers are really close together. Now, what you'll see more often, especially in this class, because we're usually not just looking at one thing, we're usually looking at a lot of things, is a back-to-back stem plot. They're useful because they're easy to compare distributions. So what we're going to do is we're going to make a back-to-back stem plot with the female and the male weights from the previous page. So it doesn't matter which side is which. I'm going to put female. Just make sure you label. So I'm going to put female weights on the left-hand side, and we're going to do our male weights on the right-hand side. So you need to go from 90 to 225. So I'm going to start at 9 and go all the way to 22. So 9, 10. Okay, so you want to make sure this, again, the same scale. So let's go through and do the female weights first since it's right above us. So this is 93, 99, 100, 104, 109, 111, 113, 113, 121, 125, 126, 128, 142, 159, 185. Okay. Now for the male weights, I'm just going to kind of go through it from the other page so you don't have to flip back and forth. So we had 97, 102, 117, 128, 130, 132, 139, 147, 154, 162, 166, 189, and 225. So there's our compare. So usually when we have a distribution like this, there are 4 key things that we need to look at for a distribution. And the way to remember them is socks. So you're going to hear me just say socks. Don't forget to do socks. So each one stands for something you need to compare. So the first one is the shape. And we'll talk about that in a second. Number 2 are outliers. The C here is for center, and the last one's for spread. So those are the 4 key things that you need to look at when you're comparing distributions. So here are the key words that you use. So I'm going to go through a little of each of these. We're obviously going to get more in depth. By the end of chapter 4, you're going to know a lot more about outliers, a lot more about the center, a lot more about spread. Shape really doesn't get much more in depth than what we're going to talk about today. So we're going to start kind of easy, things you already know, and then we'll get more in depth. So here are your key ones for shape. So the shape of a distribution. So there's a couple big ones and then some you don't see as often. The biggest one that you'll see, and we're going to use a lot later, is approximately symmetric. And that looks kind of like a normal distribution. Approximately symmetric. Don't use the word normal. If you use the word normal, you'll get marked down because a normal distribution is very, very specific. We'll talk about it in chapter 7. So we just say it's approximately symmetric, and it doesn't have to be a perfect bell curve. Okay, then uniform just means that, like, you know, especially with a histogram, you might have like almost everything's about the same, you know, a couple of ups and downs, but another big one you might see is bimodal. And bimodal just means there's 2 distinct groups. So you may have a thing that like goes up at one point, down, and then up again. So we have 2 distinct groups where it's bimodal. And then the other 2 big ones are skewed. So you can either be skewed left or skewed right. Now be careful. Where the skew is where the tail is. So a skewed left distribution is really small at the left side and then goes up into a big hump. So this is a skewed left distribution. Skewed right is the humps at the beginning and then goes down. So here's how I remember it. I do this every time. I look at the distribution and I kind of pinch my fingers. Wherever the tail is, whichever way I go. So here I'm going to the right, it's skewed right. Here I'm going to the left, it's skewed left. So approximately symmetric and the two skews are the three big ones. The other two you'll see every once in a while. So those are our 5 key names for shape. So again, these don't get much more specific than that. We'll talk about normal later. So I should see one of these. Now for outliers, there's no specific definition for unusual values, but things that you should also consider within that outlier section. First of all, for now, outliers are just data values that fall out of the pattern. Either they're too big or too small than everybody else. There's actually a rule, we'll get to it in chapter 4. Sometimes you can talk about clusters if there's isolated groups, or you can talk about any gaps if there's large spaces. So this is all in that O section for outliers. Again, we're going to learn more specific ways to describe center and spread in chapter 4. But for now, if you're going to do the center, try to find a typical value or a single value that would best describe the rest of the data. Often it's either the mean or the median. And you learn these kind of, I don't know, at some point. But remember, the mean is the average, the median is the middle. So you can do either one. Just make sure you specify, like don't just say like the center of the distribution is 5. Well, is that the mean or the median? Depending on which one, how many numbers there are, will depend on which one you want to do. And then the last one, to describe the spread, consider how close the data values are to the center. For example, they are consistently close to the center. There isn't much spread. We're going to talk about variability a lot in this class, so you can talk about that. For example, most of the data is within 3 units of the center. At the beginning, we sort of just used the range, which the range is the max minus the min. So for now, start there, and then we will kind of keep going. We'll learn more about spread in chapter 4. So here's another example. We're going to take everything we just learned and describe it. Minitab is a computer program for stats. You'll see a lot of it. We're not actually going to have you do any of it. You just see the data. It shows the distribution of the number of licks needed to finish a Tootsie Pop. So the leaf here is the ones. So again, we're going to ignore this. This is the Minitab. It's like numbers from the center or something. So we have 53 data values. So I'm guessing like if the leaves are the ones, this was like 0 licks. And this was like 600 or 62, 64 licks. So like I said, that's why I don't like that key. Whatever. So let's describe the distribution. So I'm going to do it this way. This is not what I prefer that you do. I would like you to always write full sentences with context. But since this is our first example, we're going to stick with socks, just so you can kind of see a little bit of everything. So the shape here, here's how I sort of figure out shape. I'll take my pen and I'll just kind of outline here. Now if you're going to twist it to see, it's kind of skewed. Twist it so that the numbers go in order. So this is skewed right because the tail's to the right. So we'd say skewed right. Are there any outliers? For now, you would just say like potential outliers at 62 and 64 licks. There's no like cluster, but we could say there's a gap from 43 to 62 licks again, notice I'm always adding context here. The center, I don't feel like putting all these in and trying to find the median, or the mean, so I'm going to find the median. So here's one way to find the median. I'm going to go back up so you can see it. So the median, what you can do, you take the number of data values, so we have 53, add 1, divide by 2. What that'll do, that'll tell you the position of the median. So here it's 54 divided by 2, so it's the 27th number. So this doesn't tell you that the median is 27, it tells you it's the 27th number in the data set. So then all you gotta do is count to 27. So if you count to 27, your median ends up being this first 21. So that's a kind of a shortcut to find the median. Some people go through and they like cross out kind of as they go, which with 53 numbers is kind of hard to do. So the median here is 21 licks. And then for spread, we're going to do the range. It's 64 to 0 minus 0, so we'll say 64 licks. So obviously this is not what I want. If you're going to do this on the test, you're going to get like 5 points. 1 for each thing, and then full sentences with context is kind of like 1 point together. It's kind of like this is your, like when you're writing a paper. This is like your outline, and then like write the paper. So that's kind of like what you should think about in your head, but you should write it out as a full, nice paper. So that's what I'm going to do down here. I'm going to compare the distributions of male and female weights from example 2. So again, I'm going to start with the shape. So if I go back here, the shape for the males, I would say is like approximately symmetric. Now be careful, the female weights, if you're going to skew this, make sure the numbers go in order. So again, I'm going to kind of like look at it this way, but I'm going to think about I'm flipping it up. So the skew is still to the right. So it's still skewed right, because the numbers of your stems should still go in order. If you flip it this way, you're going to get the skew wrong, because the numbers are not, like, think about a number line. Okay, so I'm going to start off there. And again, I'm going to be comparing, so I'm going to use comparative language as much as I can. So the female weights are skewed right, whereas the male, you guys can't see what I'm writing. There you go. The male weights are approximately symmetric. Okay. Now let's look for outliers. So I would say, obviously for the guys, 225 is an outlier. For the ladies, I would say 185. So both have potential outliers at 185 pounds for the females and 225 pounds for the males. Okay. Are there any gaps or clusters? There are some gaps because there are some outliers, so I'm going to talk about that. Both have gaps. Males from 189 pounds to 225 pounds, and females from 159 pounds to 185 pounds. Okay. Let's do range, and then we'll do center last. It doesn't matter the order. So for the guys, I gotta subtract. The range is 225 minus 97, so 128, and the ladies is 185 5 minus 93, so 92. Okay. So the female weights are closer together. Their range is 92 pounds, whereas the male weights have a range of 128 pounds. Okay, now the last one is the center. So let's do median again. So the median here for the guys, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13 numbers. So do 13 plus 1 divided by 2, I get the 7th number. So 1, 2, 3, 4, 5, 6, 7. For the ladies, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So 15 plus 1 divided by 2 is 8. So I want the 8th number. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So it's 113. So 139 and 113. So last sentence, the female median is at 113 pounds, which is smaller than the male median at 139 pounds. Okay, and again, I use some comparative language there. Smaller than, closer together, using the word both. So it's not like just a list of 8 things. It's like compare them. So this is what I should see on a quiz or a test. Again, it's usually 4 or 5 points. Okay, and the last thing we need to talk about, stem and leaf plots are nice and dot plots are nice if you have small data sets. Sometimes we have a larger number of observations. So you'll see we'll use a histogram. And honestly, you're not going to make a lot of histograms. You're probably going to read them more. And sometimes along with those, you'll see a frequency distribution. So here we're going to look at the number of siblings and the frequency that they have. So construct a frequency histogram. So again, the only difference between a histogram versus a bar chart that we did, a bar chart is for categorical data. A histogram is for numerical data. So in a bar chart, there are spaces between the bars. In a histogram, there's no spaces. And what I mean by no spaces is like you can still have a gap, but there's no spaces like between each bar. Whereas here, there's spaces because they can be interchangeable. So here my title, I'm just going to write how many siblings and this is going to be frequency. Just go by 1. We reach to the top. And then down here is the number of siblings. So for now, for 6, I'm going to go make these too wide so you can see better. So for 0 siblings, we had 6 people. And I'm going to shade again so you can see better. For 1 sibling, that was all the way up to 11. For 2 siblings, we had 5. And 3 siblings, we had 3. Again, what I mean by there's no spaces, look how there's no spaces between each bar. You could still have a gap, like let's say we had one person who had 5 siblings. So you can still have a gap, you just aren't interchangeable. So each bar corresponds only to one value. The center of each bar is above each corresponding value. Make sure you label your axes and your scales. And the bars and the histograms should touch. Again, unlike bar charts for categorical data. So a lot of this, was a lot today. But we're going to see more and more, especially with socks. We're going to get more in depth with outlier, center, and spread kind of as we go throughout this chapter. So you don't need to memorize all of this tonight. You got some time.